All right, today, a little bit of review of yesterday. Yesterday we would take things like these two functions, f of x and g of x, and find the domain of f, which, by the way, would have been that 3x plus 5 greater than or equal to 0. So therefore, if I skip a couple steps, and it would be negative 5/3, x greater than or equal to negative 5/3. Raise your hand if you had that one right. Okay, good. Almost everybody. Then there's the x not equal to 8 here. I could have written out x minus 8 not equal to 0 and solved it, but there's domain of g. And now, what do you do to find the domain of f plus g? You see where these two will overlap. So if I asked you to do f plus g of x, that means add the two functions. Everybody go ahead and do that. These are kind of simple to add because you can't put the square root with other stuff. Okay, now the only exception to that would be if on the test they said that you must get a common denominator and combine the two functions. If they said that, do you get the denominator over on this function as a 1? How in the world would you get them to have a common denominator? Yes?
You can multiply the 3x plus 5 side by x minus 8.
Multiply by x minus 8 on the top and the bottom, and you're right, it would have a common denominator then. And that's the only complication there could be with that, is if they said, must find a common denominator. Okay? All right, so there. That's how you add a couple functions together. How do you get their domains? Well, the domain is just the two domains, the separate domains. The domain of f intersected with the domain of g. And I'll draw them out. Domain of f is this one, negative 5/3. And it goes like this. And then the domain of g is it can't equal 8. So here's an 8. Can't equal 8, but it can equal everything else. Don't forget a domain isn't what it's not equal to. It's what it is equal to. Okay, there. And then where do they overlap? Between here and here. And there and there. Would you please write the final answer for my domain in interval notation? See if you've got that part down. If you haven't noticed, we're starting to combine a lot of things together that you've learned already so far. Like, for instance, how to find domains for single functions, how to do common denominators, how to do intersect, and then how to write the answers in a notation, interval notation. Those are all things we've covered so far this year, and it's all happening in one problem here. Okay, you should have said, actually, I'm going to get Dice of Destiny to tell me who should answer this question. It's row 1, person 4. That's you, Miss F. Tell me, what did you say the intervals were? Bracket. Tell me about the bracket. I'm not saying you're wrong, but tell me about the bracket. It includes negative 5/3 on both of them. So yeah, you have to say that it includes negative 5/3. Okay, and it goes until parenthesis or bracket. Then what? Very good. That is how you write it in interval notation. Raise your hand if you had that one right. Okay, still getting almost everybody on these. This is good. Now, what's different today? Okay, what's different today is just that we're going to go beyond the most complicated one of yesterday, which was where, do you remember yesterday if we divided two functions, there was a complication? I better do another one of those. Okay, I'm going to remind you how this works by saying, what if the question wasn't f plus g of x? We're going to go back and just redo this whole problem again, except not f plus g. but we're going to divide two functions. Keep the domains because their domains are still the same. But this time we want to know what is g over f of x. Do you get that that's the same thing as me saying g of x divided by f of x? That's what that means. I got the g function, I'm dividing it by the f function. So first, go ahead and divide those two and see what you get. Then try to figure its domain out, and hint, it's got 3 number lines overlapped. Let's see if you remember the third number line. Everybody knows that f's going to be one of the number lines, and domain of g is going to be one of the number lines. Okay, and instead, top 20 thing, fraction over a fraction. Supposed to know that it's multiplied by reciprocal. Putting this over 1. So 1 over 3x plus 5. That times that. Do you have to simplify that further? Not really. I mean, the top, I guess 2 tops would multiply it out to just be 1. That's pretty easy. But the bottom, you cannot multiply a regular x minus 8 in with the square root. You can't like distribute that out or anything. So that's it. We're done. We've done g divided by f. But where's the complication? In the domain. When you divide two functions, pay attention. You have domain of f, domain of g, and who remembers the third thing you got to watch out for on divide, but you don't have to watch out for on the others? KT.
Domain of g divided by f because the square root can't be 0.
So what can't be 0? You're right, square root, but use the function name. Which function can't be 0? F. So we say f not 0. That's the third number line. Why? Because the function on the bottom, normally functions can be 0 and it's no big deal. But now it's on the bottom. So that means now f function can't be 0. So you have 3 number lines. 2 of them we already know. Domain of f, you can just look it up. It's that bigger than or equal to negative 5/3 thing. And g not equal to 8. That means it can be everything else. It just can't be 8. And then the third one is what makes f 0, because we don't want that. So what makes f 0? Oh yeah, it's that same number. Negative 5/3 will make it 0. So now we're saying here negative 5/3. It can't be that after all. And then these 3 number lines give us our final domain for that. I'm a big believer in review. There, we just completely reviewed yesterday, even the toughest part. So hopefully you can write those intervals and you'll have your answer. Okay. Is it going to get more complicated? Of course. This is just yesterday. So what's today? Today is where you don't have 4 number lines. No, it's not like that. But today we've done add, subtract, and multiply and divide. What the heck else is there about functions? When a function eats another function. F of g of x or g of f of x. So we'll start just by talking about, what do you get when you have f of g of x. So here's an f of x for you. Here's a g of x for you. Now let's say, let's start you off with a couple easy ones. What's f of g of, oh, I made a mistake in there, sorry. F of g of 2. F of g of 2. F function ate the g function, which ate a 2. So you start on the inside. G of 2. I'm going to put 2 right there. Put 2 right there. And that's square root of 0. Ooh, that's weird. Is that like undefined? No. Square root of 0 is just 0. So this turns into just 0. Because g of 2 is 0. So now I get f of 0. What's f of 0? Put the 0 in the f function, which is right here. And I put a 0 in there. I get 3 parentheses instead of the x, and I drop in a 0. Final answer, 4. Raise your hand if you had 4. Okay, good. Thank you for catching on to that. Now, do you remember, we've done this before. If I don't have a number inside there, I just say x. What is f of g of x? The f function ate a g function, which ate an x. Write down what you think the answer to f of g of x is. In a moment, I'm going to ask you to compare. So you and the person next to you have got the same exact thing. Look for parentheses. Make sure you have a square root in it, otherwise it's not right. Okay, and these 2 rows, you're going to go straight across. These 2, you all have somebody right across from each other. These 2, you guys are going to make a group of 3 up here. You guys are going to be a group of 2. And then this is straight across from you. Okay? Compare your f of g of x with them, please. I'll pause for a sec. Oh, the irony. Guess what the error is called that it just happened on my iPad, which means it died in the middle of the recording process. A domain error. Never had that happen before. Error, domain error 82. I had a domain error when I was explaining to them. All right, can't wait to share that with my colleagues. Math nerds unite. Okay, so I think what just happened, I don't think Reflector can crash my recording app. I don't think it works that way. So what I think happened is my recording app stopped recording, and then that crashed the reflector of it. So why would it stop recording right in the middle of a lesson? I have a theory. I think it ran out of space on my iPad. So that's not great news, because that means that I can't record it anymore. All that I just recorded is not going to be there. So some poor kid who's not here today is not going to get a video because I can't do it anymore. That's the way it goes. All right, so let's just continue as if nothing has just technologically went wrong there. I'm going to pause for a second. So, I know the part that you probably don't understand is right in here. And I'm going to try to give you another example of that using something called an artificially restricted domain. It's not nearly as scary as it sounds. So let's go make 2 super simple functions, and we'll do this one more time. You need to know this formula. How did I do this formula again? I started with the inside one, domain of that, and then I took the same function, notice G and then G, it's the same function, and put it in the other domain. All right, so here's our new one. We're going to call this f of x is 5x. Ooh, that's tough. G of x is 2x minus 7. Nice simple functions. But they would normally have domains of all real. But they can be artificially given any domain. It's kind of like being the boss. You can just say, that's just the way it's going to be. Because I like, why are all of our company vans painted white? Because I like white. I'm the boss. I get to paint them white if I want to paint them white. Well, you can just say, even though this would normally not have any restrictions, you can just say, oh, by the way, I only want to do this when x is greater than or equal to 0. And then for the domain of the other one, that was domain of f. And the domain of the other one, I can just say, even though this would normally have all reals, I'm going to say that domain of g is going to be that g must be greater than 2. Just deal with it. And I said g, and I should have said x, and I think somebody just corrected me and they were right. There we go. So those are called artificially restricted domains. Implied domains are the ones where you can look it up and you can like solve it yourself and figure out what the domain is. This kind they'll have to tell you, and they will. You'll see on tonight's homework. They'll just say, here's the domain. It's actually kind of nice. You don't have to figure out the domain, they just tell you. X is bigger than 2, it's the domain. Okay, now, what if I did f of g of x? Would you please figure out f of g of x and its domain using that formula I just taught you a second ago? If you get stuck, just stop. I'll pause for a second while you give that a try. Okay, I took a quick walk around the classroom and I got a lot of different answers. I got people that are kind of in the middle of it, other people that were totally done and right, other people that had done it completely wrong, and other people that have no idea what's going on. So, kind of all over the place, and that's okay. You don't have to know this yet. This is the first time you've seen this kind. So let's see how much you did know. Did you know that the f function ate the g function, and so you should have taken the f function, which is 5x, and make it eat a 2x minus 7? Raise your hand if you knew that that's how you put the one function in the other function. All right, good. Then, how do we get its domain? It's a formula one. Why? Because this kind always has formulas. And that formula would be, it started on the, where do you start? Inside or outside?
Inside.
Inside. So I'm going to go domain of g, intersected with, and then it's not as simple as just domain of f, or we wouldn't be talking about it so much. You don't do the domain of f until later, but you are going to do it later. What's in the domain of f? G of x in the domain of f. Okay, there's your formula. Now that you've got your formula, you got to just apply it. So what's domain of g? I'm looking on my sheet trying to find domain of g. I see it right there. Why is it x is bigger than 2? Because we just told you that's the way it is. That's a given domain. It's called a artificial domain. All right, so we're just going to say that x is bigger than 2. So I'm going to make a number line for that. And here's 2, and x is bigger than 2. Could you have just written x is greater than 2? Sure. But down the road, do you remember we're going to make 2 number lines and we're going to overlap them? Okay. Next is g of x. Which one's g of x? Don't say this. That's domain of g. That's not g of x. G of x is this, which is 2x minus 7. Needs to be put into what? The domain of f, which is over here, and that's the only place you could put it is in the x. So 2x minus 7 goes in here. You can't put a number into 0. I can put that into the x, and I would have greater than or equal to 0. See how this used to be an x, and now it's got a 2x minus 7 in it? Now I'm going to add 7 to both sides. And x is greater than or equal to 7 halves, which is the same as 3.5. Cool. That sounds like a number line to me, so I'm going to make a number line with 3.5 on it, bigger than or equal to And where do those two number lines overlap? I wish I had a little tool where I could grab it and drag it over, but I don't. So I'm just going to redraw it over here. Here's where 3.5 would be. Greater than or equal to is like this. And now where do they overlap? From there over. So from 3.5 to infinity. Bracket, parenthesis. How many of you had that before I gave the answer? Okay, and that's like 4 people. Okay, so we should do maybe one more of those. Is there, how about this? I ought to see where the problem is, see where it hurts, so to speak. How many of you had this function written right? Okay, so it's not that. And I know you know how to graph x is bigger than 2, so it couldn't have been that. So it must be this stuff that gotcha? Okay, so what do we do again? We took the function and we put it in the other domain. And I'm going to show you that again. Here was the function, and we put it into this domain. And the only place you could put it would be in the variable. So there. That stuff went in here, and then I solved it. Okay, I'm going to give you one more like that. Let's see if you got this. P of x, what? Well, got to get you used to the functions can be any letter, is equal to 7x minus 1. And r of x is equal to 4x. Oh, and by the way, the domain of P is given to you, even though normally it'd be all reals. In this case, it's going to be that x has to be bigger than 4. The domain of R is also given to you. Even though normally this would be all reals, I'm going to say x has to be greater than or equal to 0. So now, find P of R of x and its domain. Pause for a second while you give that one a try. Okay, so here's how this should have gone. The P function eats the R function. Here's the big P function, the big predator function, and it's going to chomp down on an R. The R function's that, so it goes in here. Now P ate R. Raise your hand if you had that one right. Okay, good. Could you multiply it out? Yeah, it'd be 28x minus 1. That'd be fine too. Okay. So what's more important is the domain. Figured out yet? This has an equation which starts with the domain of R intersected with. I started with the inside. How many of you have that right so far? Okay, good. Now, dice of destiny. Tell me the rest of this function. It's row 1, person 4. It likes you. That's a double. One day. Tell me what should go in what? Yes, R of x in the domain, the other domain, domain of G. So here's R of x. And where does it go? Into domain of, not, you said it right, I'm sure. You probably said domain of P, and I thought I heard G. So I'm going to delete this. Just give me a second to fix that. You must have said P. Okay. I'm going to put that in the domain of P, which is right there. And I now have 4x is greater than 4. Divide by 4, divide by 4. X is greater than 1. Cool. That I can do. X is greater than 1. I know that one. What's the other domain? Domain of R. Domain of R is x is greater than 0. Okay, so here's this number line. Greater than or equal to 0. And this one, greater than 1. And then if I overlap them, I'll put the one from the right over to the left side here. And where do they overlap? After 1. 1 to infinity can't be 1 though, because there's an empty circle right there. parenthesis, parenthesis, from 1 to infinity. Raise your hand if you had that one right. Sweet. We're up to almost everybody. Okay. Now, if you have to, you can always go back and watch this video over again. We went through 2 of them thoroughly from beginning to end. All right. Now we need to actually show you some of these in your homework. So, I wish I could show this on the iPad. Unfortunately, can't. So I'm going to just drag that off to the side, and in the classroom, I'll show the kids what this looks like in Schoology. Now it's homework. Okay, we are going to do the first one. First problem that you see in the homework. Pause for a second, we're having technical difficulties here. Okay, we can now see it in the classroom at least. This one is called 3.2, day 1, and we're going to do problem 1 in all of its parts. The first thing it says to do is find GOF0. I want to make sure that you understand what that means. When it says GOF0, that means G of F of 0. So G of F of 0. That's what GOF means. I'd like... You can't see that? I'll drag that over, sorry. So GOF0 means G of F of 0. Okay, so then you'd start with finding F of 0. Just a nice simple number. And then find G of that. That should be no big deal. Notice also on problem 1 that it does not ask you to find the domain of it. So all you need to do on that whole first page is number 1. All right, moving on to the second page. On the second page, number 13 is kind of a yawner because it's just all reals and there's no artificially restricted domains. So the ones that are important are number 16 and 19. Look at number 16 and 19. Do you see how it says x is less than 10? That's the domain. It's saying you don't have to figure out the domain. I'm telling you, x is less than 10. And actually it has or equal to. So that little thick bar there means x is less than or equal to 10. So we're doing number 16 and we're doing number 19. And those will be just like we just did in class. The square root one, you can figure out the the domain for that. For the f function, it's telling you the domain is x is less than or equal to 10. All right, so do 16, do 19. And we can skip that whole last page. They aren't bad problems, but these take a while. So last thing, on problem 16 and 19, if you scroll over to the right, it's got this f of x thing. You can skip on 16 and 19. I can skip the f of x thing, because it makes the formula really complicated, and I don't think we would do that to you on a test. So, all right, that cuts it down to a reasonably sized assignment. Only have a few to do. But I totally get some of you are lost. What do you do in a situation like that? Well, remember that this isn't like the test isn't tomorrow. You don't have to have this mastered yet. You could go back and watch the video where I explained how to do it over again, and maybe you're just distracted right now. And you'll get it maybe when you watch the video. Option B, could you come in tomorrow morning and I could give you some time in the morning? Yes, tomorrow's a Thursday. I can help you on Thursdays. So you can come in the morning. There's a whole hour before school starts. Come in and get some help. Option C, got a smart friend? Get them to explain it. They might explain it differently than I did, and you might get it from them. I think most of you get this, but I know there's a few that don't, and I just want to give you some options there. Okay? If nothing else, you can always come in tomorrow morning and I can try to re-explain it to you. Help you understand it. Sometimes it takes 2 or 3 times of doing a problem and checking it and looking at the key until it finally clicks in. So, all right. That's all I have for you for the lesson for today. That was called Domains of Composite Functions.